All right, so now we have our little script that we can open. It'll give us a little grid, and we can hit the escape button and close it. So the next thing we're going to do is we're going to add a ball sprite, and we're going to see if we can't get it to move. But before I do that, in the last video, I meant to explain this while loop in a little more detail. So a while loop, it's saying, I think I mentioned that it's checking to see if this is true. But what does it do then? Well, what it does is it runs all the code underneath of it, and when it gets to the bottom, it jumps right back up to the top and it says, is this still true? And if it is, do it all over again. And then it's going to check back up to the top, and it's just going to run this constantly until this finally becomes false, which in our case it only does when we want to exit the game. So the entire time ours is opening, or our game is open, or in this case our simulator is open, it's going to be constantly, as fast as it can, running through this loop over and over and over again. It's going to be doing these things, right? So that's how the main loop works. Eventually we'll slow it down because modern computers will be able to process our simple little thing way too fast, and we want to make sure that we're seeing things in real time. But for the stop motion version that we're making right now, as fast as it can is just fine. So that's how the while loop works. So let's add a ball, shall we? Let's come up here. We're going to define our sprites. And feel free, sometimes it's going to be really important that you pause the video and think about what you're doing, especially when we're talking about the actual physics side of things. If you really want to get good at the coding, it would also be important for you to pause the video and try to do the coding yourself too. Now that's less crucial for the physics side, but if you'd like to, feel free to pause the video and see if you can't make the sprite yourself without my help. Again, we've got all the functions that you'll need are inside the function example script. So open that up, see if you can't define a sprite called ball. Right, so we'll call it ball and see if you can't make that image yourself. Go ahead and pause the video. Okay. So if you got stuck, or maybe you didn't, and we're going to move forward, or we're going to do make sprite. That's the function we want. We're going to open that parentheses, and now we need a file name. So again, I'm going to come over to my images folder, and inside there I can see all these different balls. You can just pick the one that you like the best. For this one, I'm going to run with the soccer ball. So we're going to do open quotations. We're going to do images \. It'll give me that drop-down menu, but again, you could just type in ball 5 in my case. And I'm going to close the quotations. I'm going to close the parentheses. So now what we've done is we've told Python that, hey, I want you to remember this word here. I want you to remember the word ball, and when I use it later, this is what I'm talking about. I'm talking about this image right here. Right? So we haven't actually displayed anything yet. We've just told it what ball is, what ball means to us. Right? So now we're going to add in a few white lines there just because we're going to need more sprites later, so we'll just keep the spacing. So now we want to show that sprite. And again, you can pause it if you'd like to. In the example functions script, you can find the show sprite function, and you're going to want a sprite, so we're just going to call ball. And that's that. So we're going to run this. You always want to kind of check things as you go to make sure that, because if you do a bunch of stuff at once and then something doesn't work, it's hard to go back and check which part of the thing that I just did didn't work. And so if you check things as you go, one thing at a time, it'll be obvious what didn't work. The newest thing is what broke it, right? So you can see it added this ball sprite here, but it also added it in the top left corner. We kind of want it to start here at 0, 0, right? So let's see if we can't get it to do that. We're going to go ahead and a couple things here. As we code, we're going to do it one way just to show you the idea, and then we're going to kind of back up a little bit and do it a better way. So that's kind of what we're going to do here. We're going to go ahead and move that sprite, move sprite, and when you open the parentheses, it'll kind of tell you what it's looking for. It wants to know what sprite. It wants to know the X position, the Y position that you want it at. And then if you put the word false, it's going to use the top left corner of the image for the 0, 0 point of that image. Now with our ball, that's not what we want. We want the center to be the 0, 0 point, so we're going to set that equal to true. We're going to do ball. We're going to go to 100 pixels by 100 pixels. That's the position that we want. And we're going to do true. The warning siren just went off. Okay, so now if we hit run and we do we run that module, you will notice, and I knew it. My dog is going nuts up there with he always does the warning siren. Anyway, you'll notice it moved the ball to the 0, 0 position here for us. When I made this particular script or this particular grid, I made it so that 1 pixel is equal to 1 meter, right? Because I knew that our image was going to be, our screen was going to be 960 pixels across, 720 pixels down, and so we just set it to this grid so that it had, 100 pixels were 100 meters, right? Later when we want to zoom in, when we want to zoom out, we're going to need to do some conversion to get our new ratios correctly. But for this one, we can just remember that 1 pixel equals 1 meter. Sorry, I'm having trouble focusing with my dog going crazy up there. Okay, so we've got that the move to 100 to 100, but now I want to talk about something called soft coding, because what we've done so far actually has a little bit of a problem to it. Let's say that we wanted to move our ball to 100 pixels from the right of the screen. Well, then we would want it at 860, right? Our screen size is 960, and this is set to 8, or so if we subtract 100, we would want it to be at 860. Same thing with the bottom. We would want it to be at 620, right? Because the bottom of the screen is 720 pixels, so 620 is 100 up from that. So if we run this now, we've moved the ball to this position. That makes sense. That seems to work how it should. But the problem is that now if I ever want to change my screen size, say to 760 for some reason, right? Just something comes up, we decide this is the better way to go. Now the ball is still being drawn over here. And so now anytime I want to change the size of my screen, if I have, say we're drawing like 12 things, I'm going to have to go through my script, I'm going to find each one of those things, and I'm going to change the position of every single one of those. It's very tedious to do it that way. So that's really not the best way to do things. So we're going to soft code. And here's how we're going to do that. Soft coding just means we're going to use variables to represent numbers. We're going to call one screen width. We're going to set that equal to 960. We're going to call one screen height. We're going to set that equal to 720. And then in the screen size function, rather than call a specific number, we're going to call that variable we just made, screen width, and we're going to call screen height. Now at first glance, this looks like we've added a lot of extra work, right? We've just taken those two numbers and we've made them these big long words, and we've added some extra lines of code. This doesn't seem efficient at all. But the reason this is such a good idea is because now if I want this to be 100 pixels from the right of the screen, rather than put a specific number in here, what I'm going to do is I'm going to say set that ball to the screen width minus 100, right? So that's going to do the math for me, and whatever my current screen width is, same thing here. I can do screen height, screen minus 100. And so now whatever my screen width is, whatever my screen height is, it's going to set that ball to 100 pixels from this side. And so now, again, you can imagine if I had like a dozen things being drawn right now, I could go back and I could change my screen size with just this one number right here, and it's going to go through the entire script and kind of make that change for me, and I won't have to recode everything. So this is soft coding, and it's a good habit to get into, and so we're going to use a lot of soft coding when we make our little projectile. Okay, that was a little bit on the coding side, but we do want this ball to actually start at the 100 mark. So from the left side, you can just use actual numbers, right? Because it doesn't matter what my screen size is. If I wanted 100 from the left, 100 from the right, that's still going to be the pixels that I want. So we're going to position that ball there. Okay, so now how are we going to move the ball? Well, we need to assign the ball some attributes here. We're going to do ball.xpos equals, let's just start at 100, right? Ball.ypos equals 100. And the .xpos and the .ypos here, this is another instance of something where we could call it whatever we wanted to call it. We're just using xpos because we're going to be able to see that and know, oh, well, what I mean here is the x position, right? You're telling the computer that, hey, I want the ball to have this attribute and set that attribute equal to 100. I'm going to call that later. So remember that, computer. And while we're here, we might as well do xvel. We're going to set that to 50 to start with. We can change this later. We're going to do ball.yvel for y velocity. Set that equal to 0. We're going to have no up and down motion to start with. We're going to start with just horizontal motion. And while we're here, we might as well also do ball.y acceleration. We're not going to worry about x acceleration for this particular simulator. We're just going to do y acceleration. Okay, so we've got these. We've defined some attributes for our ball there, and we've set them up. Now, what we want, so right now we've got this move sprite right here at the very start. Before anything else happens, it's going to move that sprite, and that's pretty good. And actually, let's leave that there for now, but let's copy it, because when we run our main loop, we're going to want that position to change. And so we're going to start checking to see if the ball is still at the correct position. So under this, always move the ball to its current X and Y position on the screen. We're going to tab in so that we're in the main loop. And let's go ahead and let's do if. I don't want the ball to constantly move, right? If the ball is 100 or 200 or 1,000 pixels off the screen, I don't want it to keep moving to the right. I want there to be some way to kind of stop it. So let's try and do that. Let's do if ball.xpos is less than or equal to screen width. Again, you can kind of see how that's going to help us. Now we don't have to specify a number here. We can always just set it to whatever we defined our screen width to be. If the ball X position is less than the screen width and the ball Y position is less than or equal to, the screen height. All right, and I'm gonna tell it. I'm gonna use a colon here to tell it. Okay, so if those things are true, then I want you to move the sprite. I don't always want you to set it to 100. I want you to set it to whatever the ball.xpos is, and I want you to set it to whatever the ball.ypos is, and again leave that position equal to true, right? Leave that the center of the ball equal to true. Okay, so now this thing should, and we don't have any way to check it now because right now we don't have any way to move the ball, but this should start updating our ball position. Okay, so we're going to leave that there. Now, under this for event pygame.event.get, we're going to add in a new line. We're going to come up to this column. We're going to hit enter, and we're going to add in a new key. If event.type. Actually, I don't need to do it here. I'm sorry. Let's back up because this is still a key down event, so we can jump into this one. So if we press a key, and if that key, we're just going to kind of do the same thing we did with the escape key, is, let's see, pygame.k _h. So if we press the H key, what do we want to have happen here? And actually, before we do that, let's change this if to elif. Elif is a shorthand way of saying else if. So it's going to say if there's an event, and if that event is someone pressing a button, and if that button is the H key, then do this. But otherwise, right, else, otherwise, if it's this key, so it's going to check this one first, and if that's not the case, then it's going to check this next one, right? So we're going to use else if there. Okay. What do we want to have happen? So this is an important part, or this is an important time to pause the video, because now we're starting to think about the physics. Okay, so when we want the horizontal position to change, what do we want to have happen? Right now we're not so concerned about keeping track of time and things. We just want the ball to move the amount of its x velocity each time we press the H key. So pause this, think about how you're going to do that. This is crucial for understanding the physics behind the simulator that we're making. Okay, hopefully you've given that some thought here. Maybe you figured it out already, but if you haven't, here's how we're going to do it. We're going to do, let's see, ball.xpos, xpos plus equal. You could also, if this is a way of just adding whatever number we put in here. If you started by doing equals ball.xpos plus ball.xvel, that's totally acceptable, right? You did it the right way. But the people who, you program a lot, this is a little bit clunky if you're going to be doing this over and over again. So why not have a way to just take whatever the current position is and add this new thing to it? And so the way they did that, so this, again, this is correct, and it would absolutely work. Well done. But if we just want to add another value to our current value, you can do plus equals. And so now every time that we hit the H key, it's going to set our x position to whatever the x position currently is, plus the x velocity, right? Okay, so let's give this a try. Let's go ahead and run this. All right, no, but I didn't. Let's go ahead and change, before we do anything else, let's go ahead and change the screen back to the right size, shall we? All right, we want this to be 960. Okay. So I'm not seeing any errors to start with, right? We didn't get any syntax errors, so that's a good sign. And so now if I press the H key, our ball will move. So, all right, we've got it moving, and if I press the H key again, it adds, and notice if I press it once, it added what looks to be 50 meters. And when I pressed it a second time, it added what looks to be 100 meters, and now 150 and 200. And so we seem to have some horizontal motion here. Each time I press the H key, it adds some position to the ball. Okay. And eventually, so now I've pressed the H key, but I'm at the end of the screen, so I can keep pressing the H key and it's not going to move. That's our little catch there, because if you didn't put that line in, you just always set it, it would still work. It's just that the ball would keep going off and off and off the screen. We don't really want that. We want to be able to see that ball all the time. All right, so great work. I know this was a little bit of a longer one, but we now have some working horizontal motion in our projectile simulator. So that's a good step one. I'll see you in the next one.